Exercise 5, question 1 says, to use matrix operations to solve this system of equations. X plus y equals 12 and x plus 4y equals 36. So these are our two equations. And I'm going to show you what this looks like in a matrix equation, and then we're going to solve it using matrices. But before I go and do that, I just want to prove that our answer is going to be correct. So let's solve these using simultaneous equations. Now we could put this into our calculator and say solve system of linear equations and all that kind of stuff. But instead of doing that, I'm just going to do it like this. So if this is equation 1 and this is equation 2, then I can do it by elimination. So I can do equation 2 minus equation 1. X minus x gives me 0. 4y minus y equals 36 minus 12. So 3y equals 24 and y equals 8. Then if I sub that back into equation 1, I get x plus 8 equals 12, so y equals 4. And so my solution is, sorry, that's not a y, that's an x. My solution is 4, 8. Can somebody remind us what the solution of two linear equations actually is? What is this? Yes, it is x and y. It's actually the point 4, 8. It's the point on the graph where these two lines intersect. So if I was to rearrange, this is y equals negative x plus 12. All right, so something like that. And this one here is y equals negative a quarter x plus, what's 36 divided by 4? 18, 9. All right, so it's going to go something like that. So when I solve simultaneous equations like this, what I'm trying to find is the point where they intersect. Okay? So that is that as linear equations. But one of the first things that you did with matrices is use them to model this situation. So if I was to rewrite this as a matrix equation, then I'm just going to do the coefficients of each of these. So 1, 1 and 1, and 1 and 4. X and y, and 12 and 36. Now so I actually want to use matrix equations to find out what x and y is. Again, before I go ahead and do that, let's just prove to ourselves that this actually is the same as this. So if I set up, so I'm going to do this matrix times this matrix. This is a, oops, sorry about that. This is a 2 by 2, and this is a 2 by 1. So I can multiply them together, and I'm going to get a 2 by 1 as my answer. All right, so in row 1, column 1, I'm going to multiply row 1 by column 1. So I'm going to have 1 times x plus 1 times y. And in row 2, column 1, I'm going to do row 2 times column 1. So I'm going to have 1 times x plus 4 times y. And so that will simplify to x plus y and x plus 4y. So you can see that this actually is the same as this. All right. So I'm just going to get rid of that. Keep going. Oh, it's not going to let me go back any further. So let's just get rid of all of this. All right. So what I want to find out then is, what does x and y equal? So what are these two numbers? Now, I already know the answer, but I want to do it using matrix arithmetic. So if I say this matrix is called M, then I've got this. M times this matrix is equal to this matrix. In order to get rid of M, what can I do? Yeah, that's what I want to be able to do, but I can't simply do that using matrices. What do I have to do instead? Oh, yes, I have to multiply it by its inverse. And if I multiply that by its inverse, then I have to multiply that side by the inverse of M as well. I don't know why I'm always writing in red, but there you go. So I know what M is. M is equal to 1, 1, 1, and 4. So I need to work out what the inverse of M is. And I'm going to do that on my calculator. Okay, again, the inverse is going to be 1 over the determinant of M times the adjugate of M, which I'm going to work out. Oops. That's a terrible arrow. Which I'm going to work out on my calculator. So let's do that. So I've got a matrix which is 1, 1, 1, and 4. And I want to find the inverse of it, so little hat, -1. Okay, and that's a horrible matrix. I'm glad I didn't work that out by hand. It's 4 thirds, -1 third, -1 third, and 1 third. But that is the inverse of M. So I know that M times the inverse of M is the identity matrix. So identity matrix times X and Y is going to equal the inverse of M, which I know now is this horrible thing, 4 thirds, -1 third, -1 third, and 1 third. Let's just have a look at this part here. I know that the identity matrix is 1, 0, 0, 1. And then I've got X and Y. So can I actually multiply those two together? This is a 2 by 2. This is a 2 by 1. So I can multiply them together, and my answer is going to be a 2 by 1 matrix. So let's actually prove that this works. So on the top, so this is row 1, column 1. I've got this times this. So I'm going to have 1 times X plus 0 times Y. And then in row 2, I'm going to have this times this. So I've got 0 times X plus 1 times Y. If I simplify all of that, 1 times X is X. 0 times Y is 0, so I don't need to worry about that. 0 times X, I don't need to worry about that, and I've got Y. So multiplying the identity matrix by this resultant matrix gives us that. So we're happy that what we've got left then is, sorry, over here, I forgot to write 12 and 36. So now I've got this equation left. X and y is equal to 4/3, -1/3, -1/3, and 1/3 times 12 and 36. And again, I'm going to do that on my calculator. So if I press the up arrow on my calculator and it selects that matrix, I can hit enter and use it again, times a 2x1 matrix, which is 12 and 36. And it's telling me that xy is equal to 4, 8. And hopefully that's the same as what I got up here. X is 4 and y is 8. All right. So that's a lot. I'm just going to go through those steps again. I want to find out what x and y is. So I need to get this matrix on away. The only way to do that is to multiply it by its inverse. If I multiply this side of the equation by the inverse of m, I have to multiply this equation by the inverse of m. So then I need to work out what the inverse of m is, and I can use my calculator to do that. Once I've worked that out, I can multiply the inverse of m by what was our answer matrix from the question, and I can actually determine what my x and y values are. The last thing to say about why the heck would you go through all of these steps in order to get exactly the same answer as these steps, it's all about what the point of matrices are in the first place. And one of the main points about matrices is that they are a simplified way of representing data. Now here we actually only have 1, 2, 3, 4, 5, 6, 7. We only have 8 data points, in fact. But this almost exact same process would work in exactly the same way if I had 58 data points or 1,000 data points. Whereas if I had that many data points and I had linear equations, I couldn't actually do it. So matrices are how computers think about data. In computer terms, we call them arrays. And why do you have to know it? Well, matrices are part of the further maths year 12 stuff. And talking to students who've done year 12 further maths, matrices is one of those things that when you understand the processes, or you can remember the processes, they're actually pretty easy to get your head around. Right, I'm just going to stop